Hello my dear students, welcome back to NEET World, and firstly Happy New Year to all the students who are watching these live sessions. Okay, and with this new year let's have some new plans for our preparation for our IPE as well as JEE, NEET and EAP set. Okay, so first of all look at these materials. This is our C60 materials. You can utilize these materials and make your preparation more productive in this new year, and you can get a very good score in your IPE exams. Okay, right. And one more thing, we are also providing free live sessions for your EAP set preparation. Yes, you can utilize them and you can use them productively, and you can make it more effective preparation for your upcoming EAP set 2026, right? So yes, so these are the things we are giving you for this new year from our side, right? So you can utilize them and make an effective preparation for upcoming exams in this new year, right? So now today in this session, as a continuation to our discussion of IPE Intermediate first year chemistry syllabus for both Telangana and AP students, so here we will be discussing 4 marks SAQ type questions, and let us see these questions. And guys, there is a different paper pattern for first year AP students, right? Chemistry AP students. But you know, the questions that are asking, I mean, if you check the model papers that are released for AP first year students are also having similar questions, like almost same questions as like these the previous questions of IPE Intermediate right now. Yes, you can utilize this discussion even if you are from AP first year chemistry background. Okay, right. Let us start our discussion for 4 marks, that is from hydrogens and its compound. Hydrogen and its compound. Yes, this is a chapter, you can focus it for 4 marks questions. Okay, or else there is a chance to ask a 2 marks question also. Okay, so let us start our discussion on this chapter first. Look at this, hydrogen and its compounds. Okay, so here first question you need to focus here is write few lines on utility of hydrogen as a fuel. So what is the use of hydrogen, how it can be used as a fuel? Okay, why? Because we know it has high heat of combustion, like it will produces more heat of combustion, means more heat is released upon combustion of hydrogen, right? And also along with that, the byproducts formed during the combustion of hydrogen are not a pollutants, okay, because it will only forming water molecules right now. So water is not considered to be a pollutant here. If anything like CO2 gas or carbon monoxide gas, if it is releasing like hydrocarbons, yes, we can say it's a pollutant, but here it is not a pollutant. The byproducts formed here along with the heat are not a pollutants here, we can say. So look at here. So the first one is write a few lines on utility of hydrogen as a fuel. First you can see, first point here is it has high heat of combustion. What we are saying, hydrogen is an excellent source of industrial fuel. Okay, it can be used as a fuel. Why? Because it has a high heat of combustion, right? And the next one here, if you see, it has a very high heat of combustion, that is about 150 kilojoule per gram. Okay, and the next, which is much higher than that of petrol and a natural gas. So it means there is something called calorific value. What is the meaning I am saying here? Calorific value. So what is the meaning of this calorific value? So calorific value. Okay, so this calorific value is taken as heat of combustion by standard heat of combustion by its gram atomic weight or gram molecular weight. If you take, that is nothing but, so for 1 gram how much amount of heat is released, that is what the calorific value of hydrogen is very high when you compare with the hydrocarbons like petrol, diesel and all these things. Okay, so this is one of the very useful point you can remember. Okay, now they will ask in, see, for example, if I want to frame a question in JEE, NEET or EAP set, I can give you 4 examples. So H2, methane, and the next petrol, diesel, like this I am mentioning. 4 names I am mentioning, and I am asking you which is the best fuel we can consider here. So the best fuel can be given based on its efficiency or the amount of heat released upon combustion. That is what the calorific value means, amount of heat released per gram of the substance. Okay, so the calorific value of hydrogen is very high when you compare with this. So this will be the order. Okay, so the calorific value order will be like this. So which is more efficient fuel here? H2 is a more efficient fuel. Like this we need to answer the questions. Okay, so this is clear now, right? So the next here you can see since it has high heat of combustion, it produces large amount of energy upon burning. So what is the use of hydrogen? So when we use hydrogen as a fuel, since it has large like high heat of combustion, it will produces large amount of energy upon combustion, upon burning. Okay, remember this point. As it is, you can write in your own words also, but it should sync with the answer provided here. Okay, therefore you will get good marks in the exam. Right. Look at here, the next, less pollution. What is the next part I am saying? There is less pollution. Just see here, when hydrogen burns in air, the main product formed is water vapor. So if for example, I am writing H2 plus O2. What are the byproducts here you get here? So it will be H2O only. But if you burn any other thing, like upon combustion of hydrocarbons, let us take methane as a fuel here. So what happens when it is undergoing combustion? You will get CO2 plus H2. See, you are getting CO2, which is a greenhouse gas right now. So it's a pollutant here, we can say. So due to this, what I am saying, when hydrogen burns in air, the main product formed is water vapor. So which is a non-polluting. This is a non-polluting. Okay. The only possible pollutant is some quantity of nitrogen oxide is formed. What I am saying? There is some quantity of nitrogen oxides are formed at a very high temperature. These are formed at a high temperature. This can be minimized by injecting small amount of water vapors into hydrogen flame. So how it can be minimized? By injecting small amount of water vapors while burning this hydrogen gas. Okay, so vapors into the hydrogen flame. Okay, this is the important point. So you just need to remember only two things. Hydrogen, first point is what? It has high heat of combustion. High heat of combustion. Second point is what? Less pollution. Okay, these are the 2 points. That's it. Okay, just remember that headings, then like whatever the theoretical part is there, yes, that will be there in your mind when you see these names. And the third one is, it is also applicable or used in welding and cutting metals. So welding and cutting metals also it has an application. See, hydrogen is used in the form of atomic hydrogen torch. How it will be used? Atomic hydrogen torch and oxyhydrogen torch. It means for cutting of metals or any hard substances. Yes, this hydrogen torch is used. Okay, so atomic hydrogen torch is used, or oxyhydrogen torch is used for cutting welding metals at very high temperatures. That's it. Okay, and the next one is very important application is, it is used as a rocket fuel. What is it? It is used as a rocket fuel. Just look at here, liquid hydrogen, that is liquid hydrogen is used as a rocket propellant along with the liquid oxygen, okay, because of its high energy release and low molecular weight. See, hydrogen has very low molecular weight, now just 2 gram per mole. Okay, if you take 1 mole of hydrogen gas, you will be having its weight as just 2 grams right now, and it is giving very high amount of like a heat of combustion upon burning this 2 grams itself. So that is why it has a application as in rocket fuels. Okay, so liquid hydrogens plus liquid oxygen, this mixture is used as a rocket propellant because it has high energy like heat of combustion and its low molecular weight. Okay, then next, fuel cells. Yes, there is hydrogen fuel cells. Okay, so hydrogen is used as a fuel cell to generate electrical energy directly from chemical reaction without any pollution. See, hydrogen, oxygen, you are getting water plus energy. So you have a hydrogen fuel cell in your second year electrochemistry chapter. There you will be learning about this hydrogen fuel cell. But as of now, you just remember this statement and this reaction. Just H2 plus O2 gives rise to H2O, just balance the equation, and along with that energy is released. So due to this reason, we can also use it as a fuel cell and a rocket fuel. Okay, as a rocket fuel as well as a fuel cell to generate electrical energy from this chemical energy. That's it. Okay, remember these 2 points. Right. Then next we will be discussing few more things. Yes, we will be discussing few more things. Just hold on. Next, see this one. What are the important points we have here? Hydrogen gas, like water gas. What do we mean by water gas? CO plus carbon monoxide, CO plus H2 gas. This is called syn gas, water gas here. Okay, what I am saying, syn gas or water gas, synthesis gas, you can remember. Okay, the next CO plus N2, this mixture is called producer gas. What is that? Producer's gas. Okay, and next semi water gas. What is semi water gas? CO plus H2, extra part is N2, CO H2 N2. So this mixture is called semi water gas. Okay, so these gas are used as industrial fuels. So these are used as industrial fuels, just remember. Okay, right. Let us discuss few more things. Guys, if you are really following the session and if you felt these sessions are highly helpful, just click on the like button, and also you can share this session with all your friends who are preparing for IPE exams, whether they can be your seniors, juniors, or even 10th class students also, because next year anyways these sessions are highly helpful for them. Yes, you can share with them also, right? And you can see the next one, explain the terms hard water, soft water. Write a note on the following methods for removal of hardness of water. So what is mean by hard water, soft water, and what are the methods to remove that hardness of water? Okay, so now look at here. Hard water are those water which does not give lather readily with soap is called hard water. So if you see, for example, if you take sometimes if you take water from any boring or any borewell, so it won't give like a lather when you are adding it to the soap water and all, right now. So see here, water which does not give lather, okay, readily with soap is called hard water. Okay, so hard water does not give any foam kind of thing, that is what lather we are saying here. Okay, it will not be formed with this soap water. Okay, right. Then next, hard water, see why this hard water is not forming this foam and all, because it contains calcium salts and magnesium salts. What they contain? Calcium salts, magnesium salts. Particularly if I want to mention calcium chlorides, calcium sulfates or magnesium sulfates, magnesium chlorides, like that we will be having some salts from the water. Okay, when we are extracting water from the earth, so from underground, what happens? Along with the water, there will be some salts can be added into it right now. So when that salts includes this calcium, like group 2 alkali earth metals are there now, group 2 metals are there now. So their salts will be there in the calcium salts of chloride salts of calcium, as well as sulfates of magnesium, calcium, like this we will be seeing now. So when this kind of salts are present in that water, so it will not give you any foam or lather when you treat that with a soap or soap solution. Okay, so now look at here, these hard water hardness is due to presence of salts of calcium, magnesium. Okay, so this hardness is of two types. One is temporary hardness and another one is permanent hardness. So temporary hardness is caused by bicarbonates of calcium and magnesium. What we are saying? Bicarbonates of calcium and magnesium. So look at here, calcium bicarbonate I am writing. So this is what? Calcium bicarbonate. Okay, so these bicarbonate salts are there now. These are causes temporary hardness. What we are saying? Temporary hardness. So what do we mean by temporary hardness? So this hardness, whenever I am saying temporary hardness, so this can be easily removed just by heating. So if I heat that water which contains this bicarbonate salts, you just heat that water, so that you will be seeing, you will be removing this bicarbonates. So this will be get precipitates as calcium carbonate salts. Okay, it means this precipitate will be removed out by filtration. So whenever we have temporary hardness in the water, what to do? Just heat it. When you boil it, what happens? That bicarbonates converts into carbonates like CaCO3. Now CaCO3 is a precipitate. Okay, so that CaCO3 precipitate is settled at the bottom, and you can now filter it, so that whatever the hardness caused by the temporary hardness causing substance like bicarbonates can be removed easily by heating. Okay, but this is not the scenario when you have permanent hardness causing salts. What are the permanent hardness causing salts here? Chlorides, sulfates of calcium and magnesium. Okay, so calcium sulfate, calcium chloride, these are the best example you can remember for permanent hardness causing substance. Yes guys, you know the same questions are also equally important. These examples are also equally important for your EAP set exam also, because which of the following compound causes temporary hardness? By giving 4 options they will make a question like this. How easy it is? How can you identify? If it is a bicarbonate, see, if it is a bicarbonate of calcium, magnesium, yes, that causes temporary hardness. But if it is a calcium, magnesium, chlorides, sulfates or nitrates, then that causes permanent hardness. Just remember these points. Okay, right. Right guys, if this is clear, just click on the like button and let us discuss about soft water also. See, water which gives lather easily with soup is called this soft water. So when you add this soft water to the soap solution, so you just use it as a hand wash or whenever you are feeling. So what you felt? So when you use that, there will be some foam formation, so that can be considered as soft water. But if it is a hard water, there is no foam formation, you will be observed there. Okay, right. Look at here. So how can we remove the hardness of water? It means how can we convert that hard water into soft water? Okay, so there are some methods. These methods are again important. The first method is ion exchange method. Okay, what I am saying, ion exchange method, and here permutate method or zeolite process we can say. What I am saying, permutate method or zeolite process I am saying. So what is this zeolite process? Look at here. It removes the permanent hardness of water. What it will do? It removes permanent hardness of water. So how it will be removing? See, when I say zeolite, zeolite is nothing but a silicate, aluminium silicate, sodium aluminium silicate is considered as a zeolite. What is it? Permutate or zeolite here is sodium aluminium silicate is considered as zeolite. So this zeolite, what it will be doing? For example, I have hard water. So hard water containing the calcium sulfates, let us say. So what I am saying, this is our water having calcium sulfate. So due to the presence of this calcium sulfate, what happens to our water? That is making it a permanent hardness, permanent hardness containing water. Okay, so if I remove these calcium ions and sulfate ions, yes, that hardness is removed, right? So for this, what I am using is, I am using this zeolite. What is our zeolite here? So we have sodium aluminium silicate right now. So I am writing sodium and zeolite I am using a word like a Z. So no need of representing the formula completely. So just represent sodium zeolite. NeAZ indicates sodium zeolite. Now what happens is, see, these sodium ions are removed here, released into the water, and this zeolite catches the calcium salt. So now what happens? Ka Z. It means calcium is taken out by this zeolite. Like this, complete calcium ions are removed by this zeolites. Okay, so that's how the calcium or magnesium, that hardness causing salts, can be removed using this zeolite process, zeolite method. See here, I am writing NeAZ. This represents zeolite, sodium aluminium silicate plus calcium. So if any like water contains any calcium or magnesium ions, that can be removed like this. See, calcium zeolite is removed here, magnesium zeolite is removed. Okay, so what I told you, hardness is caused by only group 2 elements, not by first A group elements like sodium, like sodium, potassium. They won't cause hardness here. Particularly who will cause? Especially the second group elements like calcium, magnesium, these things. Okay, right. This now what happens? Complete zeolite, whatever the like Z free ions are there, that is carrying this calcium and magnesium ions. So now once after completely passing the hard water through this zeolite bed, that zeolite bed absorbs all the calcium magnesium ions when water is passing through that zeolite bed. Right now what happens to zeolite bed? All zeolite bed, I mean on that units, there will be catching like calcium ions, magnesium ions are accumulated here right now. So that we can call now it as exhausted zeolite. What I am saying? Exhausted zeolite. Okay, now this exhausted zeolite can be washed. It can be washed out. Why we need to wash it out? Because we need to reuse the zeolite now. So it means we need to remove all that calcium, magnesium ions on this exhausted zeolite. So for that we can regenerate our zeolite bed by washing with a brine solution. With what solution? Brine solution. What do we mean by brine solution? Sodium chloride solution, that's it. Okay, so this is how zeolite method or permutate method is used for removal of hardness causing substances from the water. Okay, then next here we have one more method. Let us see what is this second method, ion exchange method or ion exchange resin method. So what is this ion exchange resin method? See, there is a resin, okay, so it contains some cation exchange resin and one anion exchange resin. So what do we mean by cation and anion exchange resin? Just see here. This is a modern method, removes all the dissolved salts from water, producing deionized water. See, generally water is H2O, it's a weak electrolyte, it won't dissociate normally because it's a weak electrolyte. But if any calcium salts are there, if any calcium salts, magnesium salts are present, so these ions will get dissociates, like calcium ion will be there, magnesium ion will be there, and sulfate ions, chloride ions, like that we have cations and anions. We need to remove all cations, we need to remove all anions, right? So for this process, so cations can be removed. See, you can see one in this ion exchange resin method, we have one cation exchange chamber, the next anion exchange chamber. So first water will be sent through cation exchange chamber. Okay, so water from here, let us say water is passing through this cation exchange chamber. Now what happens? All the cations, this calcium ion, magnesium ions present in this water will be attached to this cation exchange resin. So now what are the groups present in this cation exchange resin? See, they should attract this cation exchange resin. This resin should attract cations now. So it means positive charge. Cations means our resin should be negative charge. Something like sulfonate ion like SO3 minus. Okay, SO3H minus should be there. Okay, sulfate like SO3H minus, like this. Other ways COO minus groups are there. So what these groups will do? These groups will attract all the cations. What they will do? They will attract all the cations. See here, we have carboxylic acid group here, like carboxylic acid, sulfonic acid group in this cation exchange resin. Now what they will do? See, for example, carboxylic acid group is there. Now what it will do? It will releases H plus ion and binds this calcium ion to this carboxylate ion. See, now they are forming as a salt. It means this resins will hold the calcium ions, magnesium ions, and releases H plus ions from this acids. Okay, so these acids, H plus ion is released. Now what happened? So all the cations are catch up by this cation exchange resin and they are releasing H plus ions. Now I can say water is acidic water. So this acidic water is passed through anion exchange resin. When we are passing through anion exchange resin, what happens? Only cations are attracted by this cation. Now what are the anions we have? For example, calcium chloride, if I say, it can be chloride ion. If I say sulfate ion, yes, this kind of ions are there. Now these anions will send through this anion exchange resin. Now what happens in this anion exchange resin? All these anions can be catched up. So how then we hold it up there? So it is easy again. There will be some groups which attracts anion. So which types of groups we required? See, to hold the cations we required some acidic groups. To hold the anions we required here something like NH3. See here what I have here, NH4OH group, some basic groups like NH3OH, something like this. If you see, all the anions like chloride ions, sulfate ions are replaced by OH minus ion when we are passing this through anion exchange resin. Okay, see, we have NH3 plus OH minus. Okay, NH3 plus is there now. So this is a cationic form and OH minus is released into the water and this chloride ion is attracted by this NH3 plus resin. Okay, so that your all chloride, all sulfates will be attached to this resin, anion exchange resin, and now it is releasing OH minus, here H plus, there OH minus. Overall water will be neutralized. So now we only have water, neutral water, like deionized water we will be having. Okay, so this is how the process is ion exchange resin method is used. Okay, I hope this method is also clear without having any confusions right now. Next method is here we have that is Colgan's method. What is that? Colgan's method. See, the name itself saying Colgan, so it means calcium gone, you can remember. So calcium is a hardness causing substance now, so you can remove this calcium using this Colgan's method. So Colgan, calcium gone method, you can remember in that way. So look at here. So what do we mean by Colgan? Colgan is a sodium hexametaphosphate. What is this? Sodium hexametaphosphate is considered to be Colgan. Okay, so sodium Na6 hexametaphosphate P6O18. So this complete combination is considered as Colgan. Okay, so this Colgan removes all the cations like calcium ions, magnesium ions from hard water by forming soluble complexes. So what it will do? So if any calcium ion, magnesium ion is found in that water, so if we add this Colgan like calcium gone, say like that is what Colgan, that is nothing but sodium hexametaphosphate. If we add, now what happens? These sodium ions are released into the water, and all this calcium, magnesium or any hardness causing material is there like cations, all will be attracted by this hexametaphosphate and form a compound like this, and that will be removed out, separated out. Okay, so hence hard water is converted into soft water using this Colgan's method. So this is the second question we discussed till now. 2 questions are completed for SAQs, like 4 marks questions for your IPE exam, right? Now we will be discussing one more question, that is, see, explain oxidation and reduction reactions of hydrogen peroxide. See, what is the formula of hydrogen peroxide? H2O2. Okay, now hydrogen peroxide can act as oxidizing agent as well as act as a reducing agent. It means what? It can undergo oxidation and it can undergo reduction. There are both possibilities are there. We will discuss one by one here. See, hydrogen peroxide shows dual nature. It can act as oxidizing as well as reducing agent depending on the reacting substance. It means hydrogen peroxide, when it is reacting with some species, depending upon this species nature, our hydrogen peroxide will changes its property. If it is acting as a reducing agent, our hydrogen peroxide act as an oxidizing agent, or if this is an oxidizing agent and H2O2 will be reducing agent. Like this it will changes. See, depending on the reacting substance, hydrogen peroxide can show either oxidizing or reducing nature. Okay, this is how you need to understand the concept, right? The next point here is, look at here. First one, oxidation reactions of hydrogen peroxides. Look what they are saying. In these reactions, H2O2 act as oxidizing agent. So oxidation reactions of H2O2, it means it is oxidizing others. Oxidation reactions of H2O2 means H2O2 here undergoing reduction, oxidizing others. Okay, so here in these reactions, H2O2 act as oxidizing agent. Guys, I hope you know, you have clarity that oxidizing agent means this is a substance, this H2O2 is a substance, or oxidizing agent is a substance that undergoes reduction and oxidizes others. See here, if you see this one, formaldehyde we have, it is an aldehyde. How many oxygens are there in the given compound? This is the structure of formaldehyde. Okay, so to this formaldehyde we are adding hydrogen peroxide. Now look at here, hydrogen peroxide gives oxygen to other substances. Now H2O2 provides oxygen. That oxygen is taken by formaldehyde and converting into formic acid. How it is converting? Yes, formic acid is produced. So here only one oxygen is there on the reactant side for the this carbon, but here you have see 2 oxygens are there to the carbon. It means oxidation, no? So this carbon is getting oxidized, formaldehyde converted into formic acid. So here our hydrogen peroxide are acting as a oxidizing agent and oxidizing this formaldehyde to formic acid. Okay, remember this one. Next, oxidation of lead sulfide to lead sulfate. See, lead sulfide, that is PbS plus H2O2 giving PbSO4 plus water. Okay, what is giving? Lead sulfide with hydrogen peroxide forming PbSO4, lead sulfate, and water is produced. Okay, next, oxidation of hydrochloric acid to chlorine gas. What is happening here? Oxidation of HCl. So HCl with H2O2. Remember this one. HCl with H2O2 forms Cl2 gas and H2O. What it forms? Cl2 gas and H2O. Next, oxidation of hydrobromic acid. That is nothing but HBr. Okay. So HBr with H2O2. Similar to the above reaction, it is giving you bromine gas. Bromine, like bromine vapors will be produced here. Okay. And you know, bromine will be liquid in state at room temperature. Remember that. Okay, bromine vapors will be absorbed first. Okay, that is indicating bromine is formed from its HBr with the usage of hydrogen peroxide. So in all these reactions, hydrogen peroxide converting from -1 oxidations to -2 oxidation state. See, hydrogen peroxide if you write, the oxidation state of oxygen is hydrogen peroxide is -1. In all these reactions, whatever we have seen, in this oxygen is removed, one oxygen is removed, only one oxygen is placed and releasing one nascent oxygen. So if you see, this is taken by the other reacting species. Okay, so now what is happening here? -1 is converting into -2 oxidation state. It means hydrogen peroxide undergoing reduction and getting oxidation for other species, and other species are getting oxidized. Okay, remember in this way. Next, look at here, oxidation of potassium iodide to iodine, Ki plus H2O2 forming I2. You know, I2 is a violet color substance. What I am saying, it's a violet color substance, and KOH is produced. Okay, in the previous case it is H2O, here it is KOH. Just remember this difference. Okay, then next, look at here, reduction reactions of hydrogen peroxide. It means hydrogen peroxide now showing its reducing nature. It is acting as a reducing agent. So reduces others, oxidizes itself. Let us see what is happening here. See, barium peroxide with hydrogen peroxide. So BaO2 means barium peroxide plus hydrogen peroxide. See what is happening? It removes oxygen from the other substances. So hydrogen peroxide takes one oxygen from the other substances. So look at here, barium peroxide, BaO2 is there, converted into BaO. What is happened here? One oxygen atom is abstracted by this hydrogen peroxide from this barium peroxide and forming H2O plus O2. So what is a common thing you need to remember is, when hydrogen peroxide is acting as a reducing agent, mostly it will be releases oxygen gas. What gas released? Oxygen gas is released. Look at here, reduction of ozone to oxygen. So O3 plus H2O2 giving rise H2O plus 2O2. Oxygen gas is released, right? So guys, you need to mention all these reactions in your exam exactly here like this to get good marks in your exam. Okay, do not skip anything. Okay, and few materials if you observe, for 8 marks questions they are providing just a value of 4 marks answer right now. So that is not sufficient and you won't get good marks. Okay, so try to choose the best material, or you can download our materials itself from MedWorld app. Okay, so just go to Play Store and download this MedWorld app from the Play Store. Okay, so after downloading this MedWorld app, just log in it using your mobile number, and after getting logged in, just in the chat box just go and mention hi or just ask for materials. Our team will respond onto this and they will provide you free soft copies. You can use that soft copies and make your preparation effective and productive and score good marks in your IPE exams. Okay, right. So what to do? Just go to Play Store, like you are installing other apps now, like Instagram, Facebook, all how you are installing. Similar way, you just go to Play Store, download MedWorld app, get logged in it, and then next say hi in the chat box. Then our team will guide you how to access that materials from the website, from the app itself. Okay, so you can use them and you can prepare there itself. Okay, right. If you same whatever I am explaining, that will be provided in our app. That is what I wanted to say here, right? The next here, reduction of iodine to iodide. It means I2 molecule converting into iodide ions. See, I2 plus H2O2 in basic medium converting into 2I minus H2O plus O2 gas is released. Okay, remember this. Next, reduction of hydrochlorous acid. It means hypochlorous acid. It is nothing but HOCl. Hypochlorous acid with H2O2 gives O2 plus chloride ion, and H plus ion is also released like H3O plus. Just remember H2O plus HCl plus O2 gas is released. In all these reactions, common thing is O2 liberation, oxygen liberation. Okay, so now hydrogen peroxide is an amphoteric reagent. What we are saying, it is an amphoteric reagent. It behaves both as oxidizing as well as reducing agent. So this property makes it highly useful in bleaching, disinfection and analytical chemistry applications. Okay, these are the points you should mention during the exam. Right, let us discuss few more questions. Look at here. Explain with suitable examples for the following. First one, what are mean by electron deficient compounds, electron precise compounds, electron rich hydrides, electron rich hydrides. So just see here, electron deficient compounds of hydrogen. What we are studying now, electron deficient compounds of hydrogen. So these compounds have less number of electrons than compared to the normal covalent bond formation compounds. Okay, they have less number of electrons when you compare with the normal covalent bonded compounds. For example, here you can see these hydrides can be formed by 13th group. See, normal covalent bond containing compounds means what? I am writing methane. How many covalent bonds are there around the carbon? 4 bonds are there, like this right now. So it means how many electrons are there in this molecule? See, each bond contains 2 electrons, therefore totally 4 bonds are there, 4 to the 8 electrons are there with this methane molecule. Okay, now what I am saying here is, this is electron deficient compound. What is the best example of electron deficient compounds? B2H6. This is a diboron molecule. See, similar to B2H6, if you take ethane, C2H6. So C2H6, just look, formula is somewhat similar now. Here H6, H6. Here C2, here B2. Okay, but this is electron precise one. Okay, normal all covalent bonds are there, octet is fully fulfilled. Okay, so required number of electrons are present here in this compound. But if you know, if you look at this compound, it has only 12 electrons. It has 14 electrons which are sufficient, but here only 12 electrons are there. It means 2 electrons are less when you compare with the normal molecules. So this can be considered as, this is a hydride now, hydride of boron. So this can be considered as electron deficient compounds. What I am saying? Electron deficient compounds. For example, see, such compounds are usually formed by group 13 elements. See, boron is a group 13 elements, boron, aluminum, gallium, indium, thallium, these things. Okay, next, they are electron deficient because they do not complete their octet. They do not complete their octet. Example is diboron, B2H6. In diboron, boron has only 6 electrons in its valency instead of 8. Therefore, it is making it to be electron deficient. In diboron, there is only 6 electrons in the boron, so that making it to be electron deficient, because normally a molecule should contain, a carbon in a molecule should contain 8 electrons. That is what octet rule configuration we are saying. So boron should also contain 8, but it containing only 6. So this is why we are calling it as electron deficient site, electron deficient species. Okay, electron deficient compounds. The next, electron precise compounds of hydrogen. Electron precise compounds of hydrogen. Just now we discussed about methane molecule. So carbon, hydrogen. Yes, this is hydrides only now. So it contains a required octet number of electrons. 8 electrons are there. All the valency orbitals of carbon is fully filled. Yes, we can say this is a required number of electrons, means it's a precise compound, electron precise compound. See, in these compounds have exactly required number of electrons for forming a normal covalent bond. So how many electrons required for forming a normal covalent bond? That many sufficient number of electrons are present. Okay, so they follow octet rule completely. What they will do? They follow octet rule completely, and these are formed by group 14 elements. How they formed? Formed by group 14 elements, and have and they have tetrahedral geometry. What they have? They have tetrahedral geometry. And the next, if you see, example is methane, CH4. In methane, carbon forms 4 single covalent bonds with hydrogen atoms. What they will form? In methane, carbon forms 4 single covalent bonds with hydrogen atoms. Okay, so like this, 4 single covalent bonds are there, no? Sigma bonds are there. That's why each bond contains 2 electrons. That's why we are saying it as 8 electron. This is what precise required number of sufficient number of electrons are there in the valence, na? So that's why we are calling it as precise compound. Okay, in the similar manner we have few more compounds to discuss here. Electron rich hydrides. Okay, it means these are also nothing but compounds of hydrogen with some other element which has little more extra electrons. It means, just look at here, these compounds have more electrons than required for a normal Lewis structure. Okay, so they contain lone pair of electrons and act as a Lewis basis. How do they act as? They act as a Lewis basis. What they contain? They contain lone pair of electrons on it, act as a Lewis basis. So these compounds are formed by 15, 16, 17 element, group 15, group 16, group 17 elements. Best example is ammonia. So if you write the ammonia, like nitrogen, hydrogens, only hydrogens and nitrogens are there now, right? And you can see here there is a pair of electrons on it, nitrogen. So this can be donated to the other species. So what we can say, right? So there is a pair of electron now. So this pair of electron is present means, yes, nitrogen of hydrides of this nitrogen, you can say this is an electron rich hydride. Can we say electron rich hydride? Yes, because there is a presence of one non-bonding electron pair, that can be considered to be electron rich hydride. Similar to this, if you take water molecule also, yes, water also contain oxygen and hydrogens only, and oxygen atom, if you see, there is a pair of lone pair electrons right now. So that can be donated to other species, so can be considered as electron rich species. So these electron rich species, electron rich hydrides can be, electron rich hydrides can act as Lewis bases. It means if any species donating pair of electron to other electron deficient species, you can call this as electron rich species as Lewis bases. What I am saying, Lewis bases. And group 13 hydrides are there, diboron, BH3, like that, those can be considered as Lewis acids. Okay, so BH3 can be act as Lewis acid, and here NH3 and H2O can act as Lewis bases. Why? They have lone pair electrons to donate, and boron in diboron will be having like BH3 unit. If I take, it has a vacant orbital, so it is accepting pair of electrons, means a Lewis acid. Okay, so these are the points to be remembered, and extra point here in short I just mentioned here as a quick revision purpose. Group 13 forms electron deficient hydrides. These are less electrons it has. Group 14 hydrides are having exact electrons, then we can say electron precise hydrides. Example is methane. Next, group 15, group 16, group 17 forms have excess electrons and considered to be electron rich species. That's it. Okay, so these are the points to be remembered from hydrocarbons, hydrogen and its compounds. And the next one more question we have here is, mention any two uses of H2O2 in modern times. What are the uses of H2O2 in modern times? See, it can be used as a bleaching agent. What? It can be used as a bleaching agent. So used for bleaching of air, wool, silk, feather. Okay, just take hydrogen peroxide. Have you seen, when you see some salon shops and all, they will be bleach the hairs. They will change the color, like black hair will be now sometimes we will be seeing golden brown color like that right now. So what is the purpose they are doing? With what chemicals they are doing? So that whatever the chemicals they are using, whatever the things they are using, that creams or that whatever the creams they are using or whatever the material they are using, it contains something like hydrogen peroxide and all. Okay, so if you want, you just check take any unused hair, if you have anything like wool or anything, if you see, just add some quantity of hydrogen peroxide. Now what happens, that hydrogen peroxide converts black color into golden brown or yellow color, golden yellow color or golden brown color. So that is nothing but bleaching purpose here. What is happening? See, used for bleaching of air, wool, silk, feathers. So it can act as a mild disinfectant also, and it can be used as a cleaning agent. Okay, so hydrogen peroxide can act as disinfectant and a cleaning agent. So why it is? Because hydrogen peroxide undergoes decomposition and forms H2O plus O2 gas or oxygen, nascent oxygen is released. So this nascent oxygen is responsible in bleaching process. In this bleaching process, what is responsible? Whatever the oxygen gas released from this hydrogen peroxide decomposition is responsible for the bleaching agent property of hydrogen peroxide. And then next, if you see, hydrogen peroxide can also act as oxidizing and reducing agents. Already we have studied hydrogen peroxide can act as both oxidizing reducing agents depending upon condition. Okay, it is used in manufacturing of sodium perborate. So sodium perborate, sodium percarbonate, these things are used for bleaching, like washing soda we are saying now. So for that purpose, hydrogen peroxide is also added so that it will be used for bleaching process. Okay, cleansing process. Okay, the next, it is used in industries like textile industry, paper industry, pulp, leather, oil and fat industries. Okay, so for bleaching purpose, it provides chlorine free bleaching process which is environmentally friendly, eco-friendly thing you can say. So it provides what? Chlorine free bleaching process which is environment friendly. Okay, and it is also used in medicine and surgery. See, it is used as a mild antiseptic for cleaning wounds and mouth rinsing. Okay, cleaning wounds and mouth rinsing process it can be used. It is also used for sterilizing surgical instruments. Okay, next, it can also be used as a fuel. So 90% solution of hydrogen peroxide is used as a propellant fuel in submarines, rockets, and the next, on decomposition it releases oxygen and heat energy. What happens upon decomposition? Releases oxygen and heat energy along with the production of water. Okay, and you know, it is used in art restoration. What is purpose? Other purpose, it is used to restore old lead paintings and clean metal surfaces by removing stains and oxidation layers. Okay, we can remove that. See, we know lead paintings and all, if any metal is there, it might undergo oxidation forms, some oxide forms, right? Now metal oxide forms will be formed. So for a longer time if you keep it undisturbed, yes, this will be the case. Okay, now to remove that stains, that oxidized stains, we can use hydrogen peroxide and remove that all the oxidized stains with the help of hydrogen peroxide. Okay, so the next, hydrogen peroxide is a versatile chemical used as a bleaching agent, antiseptic, fuel and oxidizing agents in various industrial, medicinal, scientific applications. Okay, so these are the importance of hydrogen peroxide. So what is the main important question you need to remember about hydrogen peroxide we have seen, right? And the next, hydrogen peroxide, its preparation, properties, uses. Okay, this thing. And the next, we have seen electron rich hydrides, precise hydride, deficient hydride, this question. And the next one more, hardness of water. What is mean by soft water, hard water, and how can we remove hardness of water? What are the methods we have? Yes, these are the important questions to be focused from hydrogen and its compounds. Okay, hope all the questions that we discussed here are clearly understood. If any confusions or any doubts are there, you please mention in the chat box. We will be covering them in the upcoming sessions, and feel free to ask your concerns or mention your concerns in the chat box. Okay, so thanks for watching. You can share these sessions with all the students who are preparing for IPE exam, as well as if the students are preparing, if your friends are preparing and looking for support for their IPE, EAP set, JEE, NEET, you can share with them, because we are conducting for every subject. For example, I will be taking every day one chemistry for IPE exam, upcoming IPE exams, as well as one session for EAP set in these live sessions. In this channel itself, every day 2 live sessions for each subject is going on. You can join them and make your preparation more effective and more productive. Thanks for watching. Stay connected. Happy New Year once again. Thank you.